Manufacturers cutting metal into rectangles that are 20 inches long by 35.25 inch wide. Each metal's length and width must be within a quarter of 0.25 inches of the desired size. That's what a quarter means. Write inequalities that describe the acceptable range for the length and width. Now, when it's asking for the range, you want to first go to a number line. Okay. Okay, you're not going to put 0 in the middle, though. 0 makes no sense for length and width. Okay, just leave that open for now. So you're going to go to a number line for both of those. Okay. Okay, now what you need to determine when you're looking for a range is the variation amount. Okay. When you look within, that's your variation amount, within 0.25 inches. Okay. So what you do is you put 0.25 there. Now, here's how you find the range. What's your length supposed to be? Long means length. There's long, it's supposed to be 20 inches. But the variation means it can go over by 0.25 inches or it can go under by 0.25 inches. Okay. So what you do is you add and subtract. That's called addition subtraction. The variation amount, 0.25. Okay. So I just make two things right there. So 20 plus 0.25, that's going to be 20.25. And then you take 20 minus 0.25, and that's 19.75. Okay, so your length can be anything. It can be equal to these, so you close the circles, or it can be anything in between. Okay. Now I need that label because you have to write the inequality. So use L as your variable, put 19.75 on that side, and put 20.25 on this side. Now you got to get the signs right, okay? You really do. Now, I'm going to illustrate again how this works. Let's pick a number in between. Heck, let's just pick 20. Don't, just bring it up here. So put 19.75, just put L as 20, and put 20.25. So this would have to eat the bigger number 20. This would have to eat the bigger number 20.25. That is why they both need to be less than signs. Okay? Whenever it's between the two, both less than. Okay? Now the width. Now what's your width supposed to be? Well, the width is supposed to be wide, so 35.25. And then you add and subtract that variation amount, 0.25. Okay. So 35.25 plus 0.25 is 35.5. You just add those. It's going to say 35.5 or 50. I don't care. Then 35.25 minus 0.25 is 35. So you can be equal to those amounts. That's the lowest you can be equal to. That's the highest you can be equal to. So then you connect them. You can also have a width of anything in between those amounts. So use W as your variable. You put 35, you put 35.5. And as I illustrated up there, they both need to be less than signs. Okay, and then you're done. Okay. The ideal circumference of a women's basketball is 28.75 inches, 28.75 inches. The actual circumference may vary by the ideal by at most 0.25 inches. Write an inequality that describes the range of the circumference, so it's just one range to find as opposed to two on the last problem. Got to find the lowest to the highest. So the circumference is supposed to be 28.75. So I add and subtract, and again, you have to find the variation amount in a range. You have to, that finds a number, you add and subtract. Okay, well it says vary 0.25. It's either going to say vary or within. Okay, so that means 0.25. So I take 28.75 and add 0.25. That's 29. That's the maximum. Then I take 28.75 minus 0.25, that's 28.5. So use C for your variable. It can be this is the lowest, this is the highest, and anything in between. So C, 28.5, 29. Remember, they both have to be less than signs, okay? And I'll illustrate that again. If you pick a number between those, like let's say 28.7, that's bigger, eats that, that's bigger, eats that. So that is why they're both less than. Equal to as well. You need to put the equals to signs, okay, because you can be equal, those circles are closed. Okay, next problem. The ideal length of a certain length of nail is 20 millimeters. The actual length must be within 0.4 millimeters of the desired size. Write an inequality that describes a range of the acceptable lengths of the nail. Okay. So, the variation amount, anytime a range you need a variation. Variation is 0.4. So the length is supposed to be 20, and we add and subtract 0.4. Okay, so 20 plus 0.4 is 20.4, 20 minus 0.4 is 19.6. So you close both the circles because you can be equal to those amounts and you can be anywhere in between. So length, 19.6, 20.4. Again, they both have to be less than signs. Equal, equal. Okay, then the last one, you just have one problem to do here. The ideal length of a horse fence is 300 feet. The length must be within 5 feet of the ideal amount. The ideal width is 450 feet. The width must be within 10 feet of the ideal amount. Write inequalities for the range of both the length and the width. Okay, so we have two of them to do. So we got to find our variation amounts. That's within. Now there's two withins. So you got 5 and 10. Okay. Well, the 5 is going to be used for the length. The 10 is going to be used for the width. Okay. See, on the first one where we had a length width, there was only one variation amount, and I just used it for both of them. Okay. Now there's two different variation amounts. Okay. So the length. Long means length. So 300. But then you add and subtract the 5. 300 plus 5 is 305. 300 minus 5 is 295. Both circles are closed because you can be equal to those amounts and anything in between. So L, put in your 295, put in your 305. They both need to be less than signs. Okay. Again, if you pick a number between these two, okay, that's going to be bigger than that, so to eat this, that's going to be bigger than whatever I pick in the middle. Okay, then the width. Well, the width is supposed to be 450, but we don't use the same variation. They gave me a different variation of 10, so 460 plus 50 plus 10 is 460. 450 minus 10 is 440. So W, you put 440, 460, both less than, and with equals.